consider the figure here with curved segments of radius A and B. The straight segments are along the radii. Find magnetic field B at point P right down there, assuming it has a current I in circuit. So my favorite part about this is you can obviously tell this was drawn with a mouse as opposed to by hand. So I do that kind of jokingly because I sympathize with the challenges of drawing electronically. All right, focus, game face. So the magnetic field due to a line is mu naught I over 2 pi r. Magnetic field due to a loop or a circle, I'll do it B0 circle. If you have magnetic field going in a circle, it's going to be mu naught I over 2r. You can use whatever mnemonic you want to try and memorize these if you have to. They're very similar and they're easy to get confused, and however you do to memorize them, is probably fine. These are generally accepted to be memorized. You're not really expected to derive these formulas. So we're going to use for a circle, and the idea here is we can just approximate. So we're going to have 4 magnetic fields here. We're going to have a magnetic field that goes like this around that loop. This one, right hand rule, is going to be around this direction. Then we're going to have this section up here, magnetic field. It's going to be, so for this arc, this part is going to be out of the page. This is going to be into the page. So you wrap your fingers. So it's going to be like so. And then for this section right here, you wrap your fingers. Here is going to be into the page and then out of the page below. So the idea is we have 2 competing magnetic fields due to the arcs. The radii, the section of loop that's on the radius, is not going to affect the magnetic field of the center here. And that's because the idea with a loop, at least, or with a line, at least idealized, you get mu naught I over 2 pi r, and that's going to create a circular magnetic field. When you have a circle, it's going to create a linear magnetic field. So you have a circle going like this, current going like that, wrap your fingers, and this is going to create a magnetic field going through it. Now, in reality, what's going to happen is you're going to get more of a looping action like this because the lines have to be connected. But we're going to approximate it like that with magnetic field just going through the center. Okay, so first thing we want to think of is which is going to be bigger. I'm going to call the bottom one 1, top one 2, and magnetic field total at point P. I'm going to say is magnetic field 1 minus magnetic field 2. And the reason I say that is because 1, the orange, is going to dominate over the purple because it's closer. They have the same current. So the 2 things that really influence the magnetic field of a loop is the current going through the loop and how the radius of the loop. And so since they both have the same current, that's irrelevant. And so the loop, the arc, that's closer to the point that you're considering is going to have the bigger impact, because when you divide by a smaller number, your overall number will be larger. All right, so we're going to have mu naught I over, I'll call it I1, 2 pi R1 minus mu naught I 2 over 2 pi R2. And for this, we're going to have I1 and I2 are the same. So I'll just write over here, I1 equals I2. And I'm going to say that R1 equals, let's see here, I'm going to, so messy, clean it up a little bit. So it looks like we have A and B. So the purple, so R2, so R1 is going to be A, and R2 is going to be B, where B is larger than, or B is less than A. Did I get that backwards? I did. I totally got that backwards. R1, which is closer, is going to be B. And A, which is larger, is going to be R2. Okay. And that's just going to affect the sign. So we can just be like absolute value and not worry about it. So, but that's kind of tacky. We should be a little bit more precise. So then this becomes mu naught I over 2 pi multiplied by 1 over B minus 1 over A. Yep, and since B is the smaller number, A is the larger number, 1 over B minus 1 over A will be a positive number. And they don't actually give us numbers, so this is all we have to do. So this is how I would approach it. So to kind of backtrack real quick, just because I went through this a little bit messier, we have 2 arcs and two radii for a total of basically 4 wires. The radii, the lines along the radii will not affect the magnetic field at the center because the wire creates a magnetic field in a circular loop around it, and if since it's kind of along the spokes of a wheel, the magnetic field will never reach P. So we just ignore the 2 radii. And then the arcs, we're going to use mu naught I over 2r. Ooh, I forgot, I put the pi in. How silly of me. Crazy. I even warned against that. For shame. So we're going to use the formula mu naught I over 2r. And basically we take the one arc minus the other arc because they're moving in opposite directions, and that gives us our magnetic field. The way you do the direction for magnetic field for a loop is, again, the right-hand rule. You wrap your fingers, though, this time in the direction of the current, and your thumb will point in the direction of the magnetic field, like so. Then we do math. So, hope that helped. See you next time.